this is very important example on the line integrals for the vector point function. So we have to evaluate this line integral of the dot product of vector point function and dr vector, where this vector point function is given to us and the curve C is a straight line from 0, 0, 0 to 0, 0, 1, then to 0, 1, 1 and then to 2, 1, 1, right? So f vector is given to us and as it is your x, y, z plane, so taking r vector to be as xi cap plus yj cap plus zk cap. So this integral becomes f vector is 2y plus 3 I cap plus xzj cap plus yz minus xk cap and its dot product with dr vector, that becomes dxi cap plus dyj cap plus dzk cap. So taking the dot product, and we know that I dot I is 1 and I dot j and I dot k is 0. Similarly for the z and k also. So this dot product becomes integral 2y plus 3 into dx plus xz dy plus yz minus x dz, right? Now they are saying that we are having the curve that joins first from the origin to 0, 0, 1, right? So this is your origin and this is the point 0, 0, 1 on the z-axis. So this is the line joining from the origin to the point 0, 0, 1. So on this line, you will notice that x is 0 and y is also 0, right? So from here, we say that dx is 0 and dy is also 0. And z varies from 0 to 1. So finding the line integral for this C1 first, we are taking x and y to be 0 and dx and dy to be 0. I have written this integral complete again over here. So this is integral of, okay, from the first term there is dx, that is 0, right? And from the second term also we are having dy, which is also 0. So we are having the third term as yz minus x dz. And z varies from 0 to 1, right? But x and y is also 0. So here I'm having x and y. So this is completely 0, right? Now along C2, line joining 0, 0, 1 to 0, 1, 1. Now what is 0, 0, 1? This point, right? And then joining to 0, 1, 1. That is somewhere in the YZ plane. That is the point in the YZ plane. You will manage to notice this. This is the point 0, 1, 1. So, that is the point in the YZ plane, right? So the line joining this point to this point. So for the YZ plane, we know that x is 0 and z is, yes, here also I'm having z equal to 1. Here also I'm having z equal to 1. So z is constant, that is z is 1, right? So from here dx is 0 and dz is also 0 and y varies from 0 to 1. And y varies from 0 to 1. Now finding the line integral for C2 where dx and dz is 0. Here I have already written this complete integral. So in this case, dx and dz is 0. So we are having xz dy and y varies from 0 to 1. But also I'm having x equal to 0 and z equal to 1, right? So for x equal to 0, we get this term to be 0. So this integral also becomes 0. Now along C3, that is the line joining from 0, 1, 1 to 2, 1, 1. Where is the point 0, 1, 1? The point 0, 1, 1 is in the yz plane. That is over here. Right? And the point 2, 1, 1, that is 2 units from the x-axis, 1 unit from y, 1 unit from z, but this point somewhere lies in the xyz plane, that is in the 3D space, right, which cannot be shown over here. Please judge from these two given points that y is constant. Here also 1 and here also 1, right? And z is also constant, 1, 2, 1. But x is varying from 0 to 2, right? So y is constant, that is 1. Z is also constant, that is 1 for this line C3. So from here we get dy to be 0 and dz to be 0, but x is varying from 0 to 2, right? Now finding the line integral along the C3 where dy and dz is 0. So already this integral is written over here, and for C3, dy and dz is 0. So we are having 2y plus 3 dx, and x is varying from 0 to 2. From 0 to 2, right? Also, y is 1 and z is 1. Using these also, y is 1. From 0 to 2, it is 2 into 1, that is 2, plus 3 dx, that is equal to 0 to 2, 5 dx, which further equal to 5, and the integral of 1 is x, limits from 0 to 2, and we get 5 into 2 minus 0, that is equal to 10. So collecting all these three integrals and adding them, therefore the integral of the complete curve C F.dr is equal to the sum of these three integrals, and the first integral is 0, second is also 0, but the value of the third integral is 10. So this complete answer becomes 10. This is the required solution. Thank you.